Bismillahirrahmanirrahim. Assalamu alaikum. Hope you all are fine. In this video, I will explain types of matrices. First type of matrix is row matrix. This is a matrix in which there is only one row. For example, a matrix M is equals to 1, 2, 3. It has only one row. So it is an example of row matrix. The next type is column matrix. This is a matrix in which there is only one column. For example, a matrix A is equals to 1, 2, 3. It has only one column. There is another matrix, M matrix, which is equals to 0, 1. It has only one column. So it is also an example of column matrix. Rectangular matrix. This is a matrix in which number of rows of a matrix is not equal to its columns, number of columns. Number of rows is not equal to number of columns. For example, a matrix A is equals to 1, 2, 3, 4, 0, 6. Its number of rows is 2 and number of columns is 3. Number of rows and number of columns is different. So this is an example of rectangular matrix. Let me write another example. 1, 0, 2, 3, 0, 0. Matrix L. L matrix is equals to 1, 0, 2 and 3, 0, 0. This is also an example of rectangular matrix. Next one is square matrix. It is defined as a matrix in which number of rows is equals to number of columns. It has equal number of rows and columns. For example, a matrix A is equals to 2, 2, 2 and 2. It has same number of rows 2 and same number of columns 2. 2 by 2, its order is 2 by 2. So this is an example of square matrix. Null matrix. Null matrix is defined as the matrix with all entries equal to 0. This is the matrix in which all the entries are 0. That is why it is also called as zero matrix. It is represented by O. For example, O is equals to 0, 0, 0, 0. This is called as null matrix. Next is transpose of matrix. Transpose of matrix is obtained by changing its rows into columns and columns into rows. It is obtained by changing the rows of a matrix into columns and columns into rows. For example, a matrix A is equals to 1, 2, 3, 0, 1, 5. Its transpose, which is represented by A, T, is equals to 1, 2, 3, which is here the row. It becomes column 1, 2, 3. And the second row 0, 1, 5, it becomes second column 0, 1, 5. It is its transpose. In this there is first column 1, 0. Here is first row 1, 0. The second column is 2, 1. Here is the second is row 2, 1. The third column 3, 5 will become the row 3, 5. Negative of matrix. Negative of matrix is obtained by changing the signs of all entries. It is obtained by changing signs of all entries. Positive signs will be changed into negative and negative into positive. For example, matrix M is equals to 1, 2, minus 5, minus 4. Its negative, which is represented by minus M, is equals to, here it is plus 1, here it become minus 1, plus 2, minus 2, minus 5, it become plus 5. It is not necessary to mention the positive sign. Minus 4, it will become 4 or plus 4. Symmetric matrix. A matrix is called as symmetric if it is equals to its transpose. कि अगर हम उसी मैट्रिक्स का ट्रांसपोज लें तो वो भी इक्वल आए अपने ओरिजिनल मैट्रिक्स के. Matrix equal to its transpose. For example, A is a matrix. It is called as symmetric if it is equals to A T. Let me write an example. A is equals to 1, 2, 3, 2, minus 1, 4, 3, 4 and 0. If we take transpose AT, rows into column and column into rows. Row 1, column 1, row 2, column 2 and row 3, column 3. It is equals to its transpose. So it is called as symmetric. 1, 2, 3, 1, 2, 3. 2 minus 1, 4. Here is 2 minus 1, 4. And 3, 4, 0, 3, 4, 0. Diagonal matrix. A matrix is called as diagonal matrix if the entry at the diagonal way, at least the one entry at the diagonal way must be non-zero. At least one entry at diagonal way is non-zero. And all the non-diagonal entries are 0. For example, 1, 0, 0, 0, 0, 0, 0, 0, 3. In this, there are two non-zero entries on the diagonal way. There may be also one entry or more than one, but it is necessary that one must be non-zero on the diagonal way. Another example, matrix M is equals to 1, 0, 0, 0, 6, 0, 0, 0, 5. It is also called as diagonal matrix because its all diagonal entries are non-zero. And all non-diagonal entries are 0. Scalar matrix. A matrix is called as scalar matrix if the entries at the diagonal way are same. Same entries at the diagonal way. But the entries which are at diagonal way cannot be equal to 0 or 1. For example, 5, 0, 0, 0, 5, 0, 0, 0 and 5. In this matrix, all the diagonal entries are same, and it is also necessary that in the scalar matrix, all the non-diagonal entries are 0. So this is called as scalar matrix. Let me write another example. 2, 0, 0, 2. This is also example of scalar matrix because the entries at diagonal way are same and the non-diagonal entries are 0. Identity matrix. It is a matrix in which the entries at the diagonal way are 1. It is represented by capital I. For example, 1, 0, 0, 0, 1, 0, 0, 0, 1. All the entries at the diagonal way are 1 and the all non-diagonal entries are 0. So it is an example of identity matrix. Another example, 1, 1, 0, 0. This is also example of identity matrix because entries at the diagonal way are 1 and non-diagonal entries are 0. The point I want to repeat is that in the diagonal matrix, scalar matrix and identity matrix, it is necessary that all the non-diagonal entries must be 0. Hope so your concepts are clear. If you like my video, please subscribe my channel and don't forget to like and share my video. Thanks for watching. Allah Hafiz.